Okay, great. We have already learned about a bunch of really useful data types. We have learned about integers, which are whole numbers, and we have learned about floats, which are numbers that understand the decimal place. We have learned about strings, and we have learned about printing strings, and we have learned about functions which encapsulate and give a name to work done on some input to produce useful output. For example, the len function, which tells us the number of characters in a string, and that's all really good. But it would be nice to be able to start making some choices, making some decisions inside longer Python programs. And to be able to make choices, we are going to need a new data type called a Boolean. So let's go ahead and take a look at what Booleans are all about. There are two of them, and the first one is a capital T, true, and we type in capital T true and press return. Python echoes that back out to us, and we can check the type with that type of function. We can say type and then inside the parenthesis capital T true. And sure enough, this spits out a new class that we have not seen before, the class Boolean. And the other Boolean is the capital F, false. And we can check this with the type function as well. And Booleans show up when you make comparisons. And here is an example of what I mean by comparison. So we can ask the question, is 0 equal to, is it the same as 0? And the way that we say is equal to is the same, is with the double equal sign. So is 0 the same as 0? Well, this is sort of a goofy example, but the answer is yes. 0 is the same as 0. And if we do this comparison, press return. Python evaluates that expression, and the answer is the capital T Boolean true. Yes, it's the case that 0 is equal to 0. Is 0 equal to 1? Well, instinctively, I would say no, and sure enough, Python evaluates that expression. And the answer is capital F, false. You can also test for inequality. So could you say, okay, the question I want to ask is 0 not the same as 1? Is 0 not equal to 1? And what is the answer to that question? The answer is yes. So this evaluates to a capital T true. Here is an interesting experiment. So one question we might have is, are strings case sensitive in Python? And we could use these comparison operators, the equals or the not equals. True. So for example, is A equal to uppercase A? And I can go either way. But using this comparison, because this evaluates to false, this tells us that Python treats these strings differently, that Python is case sensitive. Now remember here, a single equals is assignments, and a double equals is comparison. So for example, x equals 4 is an assignment. This says, okay, x is a name that points to the value 4. X equals 4 is a comparison. Is x the same as 4? So we'll have to try to keep our single equals and double equals straight as we go through more of this material. So we can test for equality, we can test for inequality. We also have comparisons for things or greater than or less than other things, just like in math class. So for example, we could say, is 1 greater than 0? And the answer is yes. Is 2 greater than or equal to 3? And the answer is no. Is -1 less than 0? Yeah. So is 0.5 less than or equal to 1? Yeah. So all of these, a bunch of different types of comparisons, but they all evaluate to one of two types, the capital T true Boolean or the capital F false Boolean. We can also check for containment in a string, which also results in a Boolean. So for example, is the string H in hello? That's pretty cool. Or you can check for a lack of containment with the delightfully human readable not in. So X not in the string hello. So we know that the capital true is so populous. What is this? Lowercase t true. Well, let's run the experiment. The answer is Python does not know what it is. Python thinks, oh, maybe you mean a variable that hasn't been defined yet. Lowercase true doesn't mean anything in Python. Capital T true, the case sensitive capital T true is the Boolean. Similarly, what is this? It's in code, so it's got to be a string. That's not a Boolean. This is just the string true. So be careful about that as you go through some of these examples that we'll work through. It's just the capital T true or the capital F false by itself that is a Boolean. Okay, so we have these Booleans. How do we use them to make choices? And this is going to be really interesting because it's going to be our first multi-line piece of Python code, and I'm going to type it out and then we'll see what it does together because it's a little bit more complicated than what we have been talking about so far. So the simplest way to make in Python is with a new keyword called if. Here is an example. Talk my why it looks so if 6 is greater than 5 colon we press return. And then we notice that the prompt has changed here from our carets to dots. Python knows that we are in the middle of something. We are going to indent 4 spaces under the if. And then we are going to do some work. In this case, let's just print that 6 is greater than 5. So print the input inside parenthesis, return to end the line, but then return one more time to tell Python that we are done. And when we do this, we have completed this chunk of code. Python executes that chunk of code and it says okay, and it prints out 6 is greater than 5. So what's going on here? We have this if keyword, that's always how it starts, and then after that, if is any expression you want, it can be as complicated as you want, but it needs to ultimately evaluate to Boolean, to a capital T true or capital F false. So in this case, we know this comparison is greater than 6 is greater than 5. We know that results in a Boolean, and we know it results in a Boolean true because 6 is in fact greater than 5. So we have this if keyword, and then we have a Boolean or an expression that evaluates to a Boolean, and then colon saying that we are done with the line. And then indented under the if is all okay that we want to do if this expression here is true, and it can be as much work as we want, and as we will see, it can be on as many as the stuff. But if it is indented, this code is executed if this expression is true. And in fact, if this expression is not true, Python doesn't even look at the indented stuff. It just skips to the next chunk of code. So for example, what if we said if 0 is greater than 2? colon, written. We see that the prompt has changed. Indent 4 spaces, and then we will print again something simple. 0 is greater than 2. So we have our if keyword. We have an expression that results in a Boolean, the colon, and then indented under the if all of the work that we want to do if this expression is true. We press return to end the line. But what should happen here when I press return one more time? Well, in this case, 0 is not greater than 2. So we are not going to do the work indented under this. And in fact, Python is not even going to look at it. It's just going to jump to the end. So it shouldn't do anything. It shouldn't print anything. So if I press return, our instincts were correct. Nothing happened. Okay. So this is a powerful idea though. So because now we can conditionally do or not do something using this if keyword and using Boolean expressions. So one more example. We could say if banana is in the string Bananarama, colon, return, indent, will print I miss the 80s. And because this expression is true, we would expect this to print something. And sure enough, it does. Great. So this already really powerful. We can now conditionally execute code. We can either do something or not based on some Boolean expression. But what if I want to take one or two actions but based on some condition? Well, we are going to need a new keyword for that. And this keyword is called else. Let's try this example together using if and using else. And then we will talk about why it is structured the way it is. So first, we are going to need some variables. Let's say that my sister is 15 and my brother is 12. And if my sister is older than my brother, colon, return, indent. In this case, we will print that my sister is older. But we are not done yet. We press return to end the line and then flush to the left. So not indented. Under the same line as the if, we will say else and then a colon. So else in all other cases, return, indent, will print that my brother is older. So we have these variables, sister and brother, and we do an initial comparison. If sister is greater than brother, do the work indented under the if. Else, in all other cases, do the work indented under the else. So given the values we have assigned to sister and brother, let's think about what should happen. And let's see if we are right. So we press return to end the line, return one more time to say that we are done. Boom, sister is older. So the key ideas here are we always start with if. And if this condition is true, we do the work indented and then we are done actually. But if it is not true, we do the work indented under the else. So only one of these lines could ever be executed. And the indenting is really important here. So what's indented under the if gets executed if the if condition is true. What's intended under the else is done if it is not true. If you want what's intended under the else is executed in the else case, cool. So now we can do either A or B based on some Boolean condition. So definitely a step forward. The conditions that we check can be even more sophisticated than the ones we have been seeing. And we can have compound conditionals using a couple on new keywords. Let's take a look at some of these. So for example, what if we said x equals 1? And we wanted to know if x is greater than 0 and x is less than 2. We can use this and keyword to combine two Boolean expressions. So in this case, because both this one, the left one is true and the rightmost one is true, the overall expression evaluates to a Boolean true. So similarly, I could say, well, is 1 less than 2 and is x in the string ABC? And or both of these true? No. So the one on the right does not evaluate to true, so the overall expression is in fact false. We can chain together as many ands and all these expressions. So we can have A and B and C and D, but all of them have to be true for the overall expression to be true. If we want only one thing to have to be true, there is a keyword for that, and that is OR. So for example, it could say, is A in hello or E in hello? And if at least one of these is true, the overall expression is true. So in this case, even though the first one is not true, because the second one is, the overall expression is true. At least one is true. So the overall OR is true. There is one more example. Is 1 less than or equal to 0 or is not in ABC? So mentally breaking down each piece, is less than 1 or equal 0? No. Is A not in ABC? No. So overall, it's still false. All right. So now that we have these compounds, Boolean expressions, we can start making some more sophisticated choices. So let's go through an example of this. So let's say that the temperature outside is, and it really is unfortunately, about 32 degrees. This is in Fahrenheit. So we assign this variable temperature to equal 32, and let's make some choices based on this. So we can say, okay, well, if the temperature is greater than 60, that's in Fahrenheit, and the temperature is less than 75, colon, return, indent. Then it feels pretty good, nice and cozy. In all other cases, else, colon, return, indent, under the else, too extreme for me. So let's think about this. The temperature is 32. So given this expression, what should happen? So we press return to end the line, return one more time to say that we are done, and we follow through to the else case. You can have as many lines of code as you want indented under the if and under the else. And just to prove this point, do one more example. We can say, okay, well, currently it is 11 a.m. and we can say, well, if the hour is less than 7, or the hour is greater than 23, colon, return, I'm sleeping. So I'm kind of grumpy. So go away. Keep indenting. So a couple of things that we are going to print in this case. In all of the cases, the store is open. So we are ready for business. And so the indenting is really important here. If we did, it would change the meaning if we don't put it. So we have to be careful about this. So given whatever it is, that's it. So about what we expect to happen. There you go. So now using if and else, we know how to take either one of the two actions, either A or B. But what if we want to be able to take possibly one of many series of actions based on some condition? We are going to need one more new keyword to be able to do this. So we will make even more choices with the keyword Elif. And actually, our example from before, comparing the age of our sister and brother, is actually a little bit of a lie. So if I scroll up here, bear with me, if I scroll up here for a little bit and we think about this problem, this is actually not true in all cases. So if my sister is 15 and my brother is 12, this does the right thing. If my sister is older than my brother, we do print the right thing. If my brother is 15 and my sister is 12, we do correctly say that the brother is older. But what happens if they are same age? What do we print? So let's say that they are both 15. If we walk through this logic, is 15 greater than 15? No. So actually, we don't execute this line and we fall back to this false statement that the brother is older when actually they are the same age. So why don't we adjust this example to correctly handle when you have twins? So it's going to start out the same as before. So could say, okay, let's and we are time travel and he is actually 15. So they are both the same age. And the comparison starts out the same as before. We can say, okay, if my sister is older than my brother, so we are pros. So if my sister is older than my brother, we print that the sister is older. But now we want to handle this tie case. So let's use Elif to handle the tie. Elif, my sister is the same as equals equals double equals comparison. Elif, my sister is the same age as my brother. So in this case, we'll print that they are of the same age. And then there is only one other case. So the catch all is that the brother is the oldest, else colon return indent. Okay, so how is this different from before? The beginning and the end are the same, but we have added this new middle part, this Elif. And Elif take a condition. So Elif is like if in that it takes a condition, and if that condition is true, we execute the code under the Elif. So what Python does when it sees this block of code is it says, okay, is this if condition true? If it is, do the work, indent it under the if, and then we are done. Skip to the bottom. If it is not true, move on to the next line. Move on to this Elif. If this expression is true, do the work, indented under the Elif, and then we are done. Skip to the bottom. And we might have a bunch of Elifs in a line. And we keep trying to find one condition that is true. And when we find one condition that is true, we do the work, indent it under that condition, and then we are done. Or maybe we have a fall through in else. That's the catch all that we unconditionally execute if nothing else was true. But we always only do one piece of indented work. But with these three keywords with if, Elif and else, now we can make as many choices because we can have as many Elifs as we want. So given all that, let's see what this does. We press return to end the line, return one more time to say that we are done. But there we go. We handled the tie case correctly in this case. So this is definitely the most sophisticated thing that we have done so far. It's a big multi-line piece of Python code. The indenting is important. The structure is important. So it's worth taking a couple of minutes here to really stare at the structure of this if, elif, else block and understand why each piece is the way that it is. And in summary, you have to have an if. So you have to have some initial condition that you are checking, and that can be a it depends on what logic you are trying to implement. If all you want to do is do something or not, all you need is an if. So you always have exactly one if. You optionally could have a catch all in else. So if you want some catch all, some fall through case, so you have an else at the bottom. And then if you have other conditions that you want to check, you have 0 to many elifs, 0 to lots of elifs that handle all of these other cases that you want to check. So it's always if 0, more elifs, and optionally a catch all else. So have a look at the structure, think about some problems that you would solve making choices with Booleans and if statements, and just digest this couple of minutes to get used to it. We have covered a lot of really great material, a bunch of basic data types that are really important, numbers, strings, Booleans. We have learned how to make choices with those Booleans. We know about the stuff, we know about variables. Now is a really good time to take a break, step back, and actually get some hands-on practice with this material to really solidify it for you. So please take a break now and work through the practice material for this section.